problem with the eigenfunction expansion, right? Solution of the problem with the eigenfunction expansion. And the problem we took up ddu by dx. So my first bench is last bench, guys. Can you please count the first bench? Now that's the problem with last bench, guys. Yes. Okay. ddu by dx square minus du dx equals to 1 and ux equals to 0 and ux equals to 1 equals to 0. These two problems are there, right? So these two boundary conditions, and this is the governing equation, and we need to solve by eigenfunction expansion. We need to solve by eigenfunction expansion, and we have last class we have discussed about the analytical solution, which was we agree with, right? Analytical solution, direct method. Analytical solution, which is q equals to minus 1 by e minus 1 plus e to the power x by e minus 1 minus x. Minus 1 by e minus 1 e to the power x by e minus 1 and minus x. Now eigenfunction expansion, if you do, well, what you will be doing? What's the eigen equation? You have seen that, yes, last class, right? And what's the eigenfunction you got? What's the eigenfunction you got? U and x equals to bn equal to x by 2 sin n by x. Okay. bn equal to x by 2 sin n by x. Okay. So if you look at the operator, this is the way the u and x will be orthogonal with this. So that means what I am saying that if you write u equals to summation cn un, any function can express a linear combination of the basis function eigenfunction. And what we can do that, which is cn c1 u1 plus c2 u2 and then cn un and so on infinity down. How to find c1? In this case, you take the inner product with respect to u1 with respect to w. Then only you get c. If you don't have w, then inner product u1 u2 with respect to w only 0. What I am saying that inner product u1 u2, you should say this way, wx u1x u2x dx 0 to 1 equals to 0. If I remove wx, that means if I say u1x u2x dx, question mark, we don't know. That's the condition. So because if ws, if you see ws is not 1, if ws equals to 1, you can say direct inner product definition is possible. But since ws plays a critical role for the orthogonality criteria of the eigenfunction, ws plays a critical role for orthogonality criteria for the eigenfunction. Okay, I think this part is quite clear. I have explained it quite a lot. So now you tell me how to find Cn. What is the equation for Cn? Cn equals to, we have done last class, Cn equals to inner product 1 u and x w divided by minus lambda u and x. U and x again. You can say w or wx. Whatever. And wx is e to the power minus x. That wx is e to the power minus x. So what is then dn? We have, so if you work out here, you get something by bn, right? And bn Cn will become bn. I want bn. Following the same derivation, what is the bn expression? What's the bn expression? Integral 0 to 1, then e to the power minus x by 2. Minus x by 2 to the power minus x into the power x by 2 is minus x to x by 2, right? Then sine n pi x dx, am I correct? Yes or no? Okay. Divided by lambda is what? Lambda is no. Lambda, how much you found lambda? What is that? That's all? Arbitrary you are telling the lambda values. See the situation of your case. Arbitrary you are saying the value of n square by pi. Who told n square pi square? How to find n square? Why you are finding n square pi square? You have to simply solve dtu by a square minus du dx equal to minus lambda x. Lambda u, right? Yeah. Does it give n square pi square? Lambda lambda. What is that? 1 by? See, arbitrary you are saying. Even that was not correct answer. What's the right answer? I am shouting, and maybe one day you will see my dead body in the class. I will be shouting, I won't have the answer. This is the level of the class. Simple thing, I cannot get the answer. Yes, Jessica. Pardon? That's all? Okay. Next is 0 to 1. Am I correct? Okay. What's the final answer? How to get this answer? This one? By integration by parts. You have to do integration by parts of this. Integration by parts. E to the power minus x by 2 sin n by x dx. Integration by parts. Integration by parts. Integration by parts. Second, the denominator term is known. You have already done it, right? Earlier. Denominator term we wrote a folio ago. Numerator part. Numerator part, what we look at? 0 to 1 e to the power minus x by 2 sin n by x dx. How to do it? Integration by parts, right? Yes. Which will be u, which will be b? Huh? N by x will be u? Okay. How much is the final answer? It's not that easy, my answer. The square root of e will be coming. The square root of e will be coming. Yes. The square root of e will be coming. I will not give the answer now. At least I see Jessica. Vasudha, are you getting anything numbers? Are you getting any numbers? Not to see? Show me. Okay, I will give the answer. The numerator part is minus 2 root e n pi. Check it out. Whether some of you got correct answer maybe. Minus 1 whole to the power n by root square root of e 1 plus 4 n square pi square divided by minus half 1 by 4 n square pi square dot 1. Any of you got it? Yes. That's what I could not put it in. I thought you write it down and okay. So now can you tell me the final answer? What is dn? What is dn? This type of problem is going to come in the end semester. So that's why I'm practicing quite a lot here in the class. At least one of such problem will be coming in the end semester. And I'll ask you to compare this result and the eigenfunction expansion result. Maybe you have to take 5 to 6 or 7 terms to get the accurate results. Okay, what's the answer for dn? 32 n pi. I will get outside the bracket. Fill in the blanks. And we have root over e in the bracket. So outside the bracket, I have got two terms 32 n pi and root e. What is inside the bracket? Let me see any of you are getting the answer. Any of you got the answer? What is that? Minus 1 to the power n, yes. Minus, yes. That's it. Good, thank you. So you got the dn value, and then your situation is ux is nothing but summation of cn un, okay? And cn un is already having dn. Cn bn is nothing but dn, okay? So your u is nothing but summation n equals to 1 to infinity dn e to the power x by 2 sin n by x. That's the solution. What you do that, go back home, take 5 terms of this. Remember that all 5 terms have to be there because there is no chance to have 0. All 5 terms have to be there and compare the solution. This kind of thing you have to practice. X equal to 0, 0.25, 0.5, 0.75 and 1. Go back home. Try to do 0, 0.25, 0.5, 0.75 and 1. Yesterday, previous problem I actually asked Vasudha, did you do it? Previous problem, how many terms you have taken? 7 terms? 5 terms. Okay, 5 terms in 0.25. What was the answer you got? Assume first 5 terms 0.25. I got minus 0.038872. I have taken 5 terms. Remember that. 5 terms, but your number and my number is not matching. Yes. Listen, I am not asking analytical solution, I am asking only eigenvalue solution. Minus 0.038872. Okay? So now you can, so similarly, you can actually do for this problem and next class you can compare again. Okay? So this problem I can tell you that again with 5 terms you can get good solution. Even 5 terms. Okay? Next, what will actually happen? Sometimes what actually happens, sometimes this function will be very complicated. Okay? This will be simple, but this function is very complicated. Okay? In that case, you will not be able to evaluate analytical. How to do that? For example, it is now 1, right? Next problem I will be putting x. Let's see the next problem. d2u by dx square, slight change, x. Analytical solution will change. This will be x. You give me the first analytical solution. I am slightly complicating the problem. d2u by dx square minus du dx equals to x. What is the analytical solution? Definitely by Wronskian method, right? Definitely by Wronskian method. Complementary function, particular integral. Complementary function was known yesterday. Same problem, right? Particular integral equations are there. What is that? u1 prime phi 1 plus u2 prime phi 2 equals to what? u1 prime phi 1 plus u2 prime phi 2 equals to 0. u1 prime phi 1 prime plus u2 prime phi 2 prime equals to x. Solve it. Get me u1 prime u2 prime. You tell me the answer. I will just verify with my notes. What is u1 prime you got? First we have to find analytical solutions. Analytical solution also we know the procedure. It has been taught. Analytical solution was taught in the first part of this portion. Analytical solutions. Analytical solution. u1 equals to u1 prime equals to how much? Correct. So u1 equals to minus x square by 2. Next u2 you got. Speak louder. No, I cannot hear. It is not 1 minus x, it is minus in bracket x plus 1 into 1 minus x. u2 is minus within the bracket x plus 1. So minus 1 into x plus 1. Should say u2 is minus x plus 1 into the power minus x. Right? Yes? Jessica got it? Okay. Now what's the value of psi? Final solution. I want the final solution. You get the complementary function already it is there. So this c1 plus c2 to the power x, u1 phi 1 plus u2 phi 2, right? And then c1 c2 values can be obtained from boundary condition. Yesterday we have done it. u1 at u equals to u at x equals to 1 is 0 and u at x equals to 0 equal to 0, right? With that we can actually get the boundary conditions evaluated, c1 and c2. You are not able to understand anything, right? You are not able to understand anything, I know that. Your face tells us. I don't know why you guys come to the class. Of course, marks is given to come to the class. I know that. Nikita, what's happening? Hey, numbers. I am only asking numbers now because I am not doing tutorial in the class. If you solve as much problem in the class, it will be easy for you to solve in the end semester. These problems are coming in end semester. That's why I am solving in the class. How much is the solution? Final solution. Yes, any numbers? There will be 4 terms. One will be constant term, one will be term with the e to the power x, one will be term with x square by 2, one will be the term with x. Now tell me the answer. One constant term, one will be e to the power minus e to the power x, one is x square term and one is x term. There are 4 terms. Solution is psi equals to, who will tell me the answer? Psi equals to psi equals to how much? There are 4 terms. What is the constant term? What is that? Yes. Constant term is? No. What is that? It is 3 by 2 by 1 minus e, right? Yes. Next term. I am asking for e to the power x. 3 by 2 again 1 minus e. Minus x square by 2 minus x. That's it. So many problems we are covering here. We are covering the previous problems in the Wronskian. We are covering also all eigenfunction expansion kind of problem. Okay. Now I think our Cn term is, this is correct, no? This will be very distinct. You don't need to worry about it. Cn will be what? X comma, which is minus lambda un. Am I correct here? Check it out. Cn is correct. What is then Dn? Am I correct? Dn configuration? Check the Dn configuration. Check the Dn configuration. Is it correct? What is that? W will vary here. What are you talking? W will vary here. What's the operator? I think you completely got lost. What's the operator? You are saying W is very dangerous and very short. What's the operator here? How can you write in operator sense? What's the operator here? If I say L, how to write operator? L equals to? What is L first of all? Non-homogeneous system. If it is U, I can agree with it is X. It's non-homogeneous system. When you are putting one, you need complaint. When I am putting X, you are complaining. One is nothing but X to the power 0, no? Is it agreeable? This is yes or no? Because in that case, what I want you are doing, this is my total problem. See why the mistakes I tell you. We have Ax equals to B. Okay, eigenvalue problem is AUI equals to lambda I ui. Did I care for this B? Should I care for this X? That's what. I have to see the operator. The operator is A. Here the operator is X d2u by dx square minus du dx. I will just simply write d2un by dx square minus dun dx equals to minus lambda w x un x. That's my eigenvalue formulation. So simple. Doesn't matter what is there right hand side. I have to locate first the operator. Then formulate the eigenvalue problem. First locate the operator. Then formulate the eigenvalue problem. The location operator says that d2u by dx square minus, if some u term is there, definitely we can say okay, u is there. That will actually constitute. That makes a row. In fact, in the exam I can ask you the problem d2 by dx square minus du dx plus lambda 1 u, where lambda is not a particular eigenvalue. I can give that kind of problem. Then what will be your solution in terms of eigenfunction expansion? That's what I'm asking. Okay. Any questions, any doubts? I'm only teaching 3 or 4 people in the class, I guess, who are interacting. Others are, I think, sort of dummy. Yes, Nikita, any questions? Any doubts? Vasudha, Jessica, everything is clear? Okay, this is acceptable, right? How to evaluate this integral? How to evaluate the integral? Earlier you said this is u. Now what will be u, what will be v? There are so many terms. What is u, what is v? Can you evaluate this integral? Yes or no? Difficult integral, huh? How to evaluate this integral? Next step is 0 to 1. You can say x, sorry, e to the power x by 2, x sine n by x dx minus d dx of e to the power x by 2 integral x sine n by x dx. Am I correct? The formula? Yes or no? Yes. Now this will be acting as again another integration by parts. X sine n by x, where x is u, right? Sine n by x is v. Here it is e to the power x by 2. You know the answer. Earlier it was e to the power x by 2 was u, right? Yeah. Okay, I will leave this thing for your home, and you can actually do it at home and again compare the 5 terms. Now the situation I will just discuss here at this point. If I have a very complicated function, I put fx. If I have a very complicated function, and this fx will come here, everything else will be same. Only this will have to change, and the solution also will change. That will calculate. Sometimes may not be possible, very difficult. What actually happens is fx could be any function, could be s to the power es to the power sin x to the power cos x whole to the power log x and all. You won't be able to find. But how to get the integral evaluated then? In this situation, eigenfunction expansion will prevent us here, because you will get this integral. Bottom integral you can easily evaluate. It's very easy. Only top integrals are having problem. I am saying fx equals to x e to the power x to the power sin x, I can say by log x, log of sin x. Very complicated function. Okay? You got up to this one. How to evaluate this integral? Numerically. Which method? Simpson is very easy. Simpson is very easy. Simpson's first is categorical rule. It won't work here. Then it is having Simpson's 1/3 rule. Then you have Simpson's 3/8 rule. Okay, they have got limitations because the accuracy is not less, not that much. It is very less. Next accurate is. So trapezoidal is less accurate. Simpson's 1/3 is less accurate. Simpson's 3/8 is less accurate. Next is, what is that? Newton Raphson. You will do integration. Great. Who told? I want to just do like this to him. Please introduce yourself. Who told Newton Raphson method? Boss. We have done masters from US, right? Yes. So now we decide whether we want to go to US or not. Now we should decide whether we should go to US, because the classic example, he has done masters from USA and he is saying Newton Raphson method he wants to do integration. Newton Raphson method is actually used for solving algebraic equations. So that shows that our India education is much better to some extent. In fact, I have done PhD from India. I had an offer to go to US. I didn't want to go that time. I think my decision was very, very correct. And in fact, my boss was saying that I leave Ureco and almost go there because I had a paper in chemical engineering science in masters. And I decided not to go to US because in India we can get the best education, and that you can see what I'm teaching. This kind of mathematics I cannot teach in US. I was working for US for 3 years as a postdoc, and if you write more than 2 by 2 matrix, the guys will not appreciate because Americans don't have much brain for mathematics. Of course, some mathematicians came out, but we cannot generalize. All Americans are very good in mathematics. Americans, if you say 3 by 3 matrix, they will start yawning. And they will be actually carrying food packet in the class. Actually, you guys are much better. They will come with fruit juice. They will come with some kind of burger, sweet burgers and all. They will keep it. Once you see good 3 by 3 matrix, they will start yawning. But if sometimes they get bored, what they will start doing that they will be eating the sweet burger and they start shipping the fruit juice. I taught them in the class. I know. They told only 2 by 2 matrix is acceptable. That's why I gave 2 by 2 matrix only. Because I want it to be compatible with US. And our US friend is there. Kudos to him. Okay. Yeah. So, good. Okay. Newton-Raphson method is not the acceptable answer. Anybody else is having any answer? Simpson's 1/3, Simpson's 3 by 8, trapezoidal all got cancelled. Then some method is that you know that if I tell you say yes I know. What is that method? Gaussian quadrature. Have you heard about it? Gauss quadrature? You have not heard. Okay. Let me take some 5-10 minutes here. See, trapezoidal rule, what you do? 2 points is A and B. This is integral fx dx. So numerical integration, what do you do? Attention please. Wy fx. So any numerical integration objective is express the integral in terms of weighted sum. In terms of weighted sum. Okay? All numerical integration based on the same formula. Weighted sum. So for the trapezoidal rule, only 2 points we take. Okay? And weighting function is how much? If I take 2 points. Weighting function is how much? Trapezoidal rule. Weighting function. I am taking 2 points. Trapezoidal rule. What is that? Trapezoidal rule, so much things you are talking about. What is that? You are taking trapezoid. What is the weighting function? What is the weighting function? What is the area of trapezium? Area is this and this. Finally, what's the area of the trapezium? What's the area of trapezium? See, I am going to school level mathematics. What's the area of trapezium? In between, in this kind of, what is that? I am putting here 0 to 1, much easier. I am putting here 0 to 1. So here W1 is half f of A plus half f of B. See, to get the half you are struggling to it quite a lot. You understand why it is half? Yes or no? Jessica? Yes or no? I don't think I understood. You didn't understand this half is coming? Pardon? Area of triangle plus area of the square. Area of this. Okay? So this side you can say h1, this side you can say h2, h1 into 1. Okay? And this is half of this into this. Okay? So that's the way actually things actually come in picture. So when you have the 3 by 8 rule or 1/3 rule, what actually happens? 3 functions comes and actually we assume this line as parabola. Quadratic term. Since 3 by 8, we assume this as cubic. This is the way all these forms are coming, and for Simpson's 1/3 n equal to 3, n equal to 3, yes, and Simpson's 3 by 8 n equals to 2. Okay. So if you go for Simpson's 3 by 8, it is quite obvious that you are going for the cubic approximation maximum. Cubic approximation maximum. Okay. And how many points you take Simpson's one third? 3 points, right? In between. Simpson's 3 by 8 you take 4 points. Trapezoid you take 2 points. So you need to have 4 points. And with the 4 points we are getting maximum approximation cubic. Now with the Gaussian quadrature, what actually happens? The rule is, I don't want to derive here. Gauss quadrature. There is a formula for approximate polynomial approximation. N is number of Gauss points. If number of Gauss points is 1, it is only linear approximation. That means for trapezoidal rule, you need 2 points to have linear approximation. Gauss quadrature need only 1 point. Why? Maybe next semester if you take my course I discuss, not this course. If you have 2 points, how much is the polynomial approximation? Cubic, right? 2 into 2 minus 1. That means for the cubic approximation, you need 4 points here. Here you need only 2 points. That means definitely Gauss quadrature is computationally more powerful. Calculation is more powerful because you need to have only 2 points to have cubic accuracy. Okay? Understood? Now, for any for the Gauss quadrature problem, there is a catch. You need to have integral in this kind of fashion, minus 1 to plus 1. You need to have integral minus ft. So how you convert this 0 to 1 in this fashion, minus 1 to plus 1? What will be your t? What will be your t? So I am saying this is my integral I. What should I write? I equals to, in terms of t, what should I write? This is a definite integral problem we have done in the school level, definite integral. How, when you convert it, your limit from 0 to 1 to minus 1 to plus 1, there is a way to convert. What is the relationship between t and x? We can put t equals to mx plus c. X equals to 0, t equals to how much you are getting? C, right? And x equals to 1, you are getting. So what will you get the relationship? Any idea? I am asking the relationship. If x equals to 0, t equals to minus 1. If x equals to 1, t equals to 1. What is the relationship between that? T equals to 2x minus x. 2x minus 1. So integral will be minus 1 to plus 1. Your fx equals to x. I am assuming fx equals to x. X will be then how much? X will be t plus 1 by 2 e to the power minus t plus 1 by 4 sin n phi t plus 1 by 2. What will be dt? dx and dt, what is the relationship? So dt will be, should I write dx or should I write dt? Dx will be how much? Dt by? numerical you have to solve. The same thing is that if you go to your numerical notes or Google, you can see the Gauss points W1, W2, F1, F2 will be given. Sorry, not F1, F2. X1, W1, X2, W2. So in that case, you will be having T1 and T2. So this will lead to have two terms. Two Gauss points I am actually using because I am assuming that I can get cubic accuracy 2 into 2 minus 1 cubic accuracy, right? So how we do learn the Gauss quadrature? Of course, Gauss quadrature is coming in the exam. If you want to learn Gauss quadrature, how to solve it? Take a simple integral x dx minus 1 to plus 1. You know the analytical solution x square by 2. You get the solution. After the Gauss quadrature, what is that? Summation I equals to 1 to 2 wi f of xi, which is w1 f of x1 plus w2 f of x1. This w1 x1 x2 w2, this is available in the Google. 2-point Gauss quadrature. You can get x1 x2 w1 w2 to the minus 1 to plus 1. Put it, get the answer, and see what result you are getting. You should be getting correct answer because your function is x and you are giving cubic accuracy. Do it at home and get the answer. So like that, you practice integral x squared dx minus 1 to plus 1. Use the same formula. When you are comfortable with, then for each n, remember that we have the summation. What is that? dn equals to, so u equals to summation n equals to 1 to infinity dn e to the power x by 2 sin n by x. So for each n, we have to do this. For each n, there are two terms of Gauss quadrature. N equals to 1, 2. If I say 5 terms, for each of these 5 terms, you have to evaluate the integral by this fashion, 2 terms. Okay? So dn is evaluated by Gauss quadrature. dn is evaluated by Gauss quadrature. Okay? So when you practice this, then you go by this method and then try out x and x square. Try out x and x square. So what I am giving the home task, fx equals to x and x square. Okay? Compare your analytical solution and numerical, assuming 5 terms for the same point 0, 0.25, 0.5, 0.75, 1. First you practice this. When you are comfortable with, come here, attack the problem. Maybe x and x square, maybe Vasudha can give it to you in next week Tuesday. I am giving enough time, not Monday, Tuesday. Next week Tuesday. It is very good for you. You have any exam? Thermodynamics when? Thursday is okay. That's why I am not asking Thursday. You can give me by Monday also, no problem. Okay? Maybe Nikita can do the x and Vasudha can do x square. Okay? You both can finish. It is actually helpful for you. Once you do it, you are 2-3 steps ahead in the 10th semester. This type of problem is coming in the 10th semester. Okay? Is there any doubt in the Gauss quadrature? If you have still any doubt, you can always practice this problem. This table is available in the your Google. I have the values, but I will not give it to you. You can actually check in the Google. You get the values in the Google, which is, I think, T1 values will be minus 1 by root 3 and plus 1 by root 3. Okay? T1 values will be minus 1 by root 3 and plus 1 by root 3. W1, I think, 0.555 and 0.99, something like that. You check it out in the Google. Anywhere these values will be available. Okay? So I will just take one last problem before getting into the partial differential equation. So we have done we have seen that how eigenfunction expansion will be helpful even if your right hand side is very, very complicated. Next problem we will be taking d to u by dx square minus du dx equals to fx, ux equals to 0 equals to alpha and ux equals to 1 equals to beta. How to solve this problem? Remember that your eigenvalue problem is not having the zero boundary condition. How to attack the problem? Here the problem is operator is same. Only problem I created for you, I put alpha and beta. So in this case, this method will be using called superposition. The method will be using called superposition. That means we will split up the problem. And the split up the problem is possible because operator is linear operator. The split up is possible as the operator is linear. As the operator is linear. The split of the problem is possible as the operator is linear. Okay. How to split up the problem? What is the exact eigenvalue problem? Eigenvalue problem can be done du by dx square minus du dx equals to fx. Ux equal to 0 equal to 0. Ux equals to 1 equal to 0. If that problem would have been there, we would have been very happy. So, I will write one problem. d2 u1 by dx square minus d2 du1 by dx equals to f of x. u1 x equals to 0 equals to 0. u1 x equals to 1 equals to 0. Another problem I will see d2 u2 by dx square minus du2 by dx equals to 0. u2 x equals to 0 equals to alpha. u2 x equals to 0, sorry 1 equals to beta. This problem is very easy to solve. We don't need any eigenvalue. Directly you can solve this problem. Okay? This is your complementary function problem. It is nothing but complementary function. And this is eigenvalue problem. Remember that whatever you do, you should satisfy u1 plus u2. Because L of u is nothing but L of u1 plus L of u2, which is Lu1 plus Lu2. Property of linear operator. If this is not satisfied, then this type of splitting is not possible. If this is not satisfied, Lu1 plus Lu2 equals to Lu1 or plus Lu2. In that case, this type of splitting is not possible. So when this type of problem is there, the objective is to have eigenfunction problem. When you want to solve this eigenfunction problem, you formulate first for the eigenfunction with the homogeneous boundary condition. Then take the non-homogeneous boundary condition with the homogeneous operator. At a time, one will be homogeneous. There is a thumb rule. At a time, boundary condition is homogeneous, operator is non-homogeneous. Yes, operator is homogeneous, boundary is non-homogeneous. At a time, one homogeneous, one non-homogeneous. If you use this, you can easily split up the problem, provided the operator is the linear operator. Provided the operator is the linear operator. Okay. Now, so I will call this as easy problem, and this